today I will tell you about the TrustInSoft Analyzer, which is a relatively innovative one, which is based on formal methods. So what is an analysis on formal methods? We'll see that. It's relatively special. It's an unusual topology. I would say the vast majority of static code analyzer use what I would call traditional techniques. This one is based on formal methods. Why it is so special? Because it's based on mathematics and it delivers mathematical guarantee of absence of bugs. And also through this mathematical guarantee, it allows you to reach exhaustive validation and verification of your software. This is an analyzer that's typically used both for safety and cybersecurity, because in our world, they're relatively close, and the use case of his analyzer are relatively similar for the two domains. Since we are particularly targeting cybersecurity and safety for embedded software, on top of being based on formal methods, it's an analyzer that has specific features that makes it particularly well suited for embedded low-level software, and I will explain that later. Yes, it's special, but also it's quite important that it has all the standard features that can be expected from a classical static code analyzer. So, for instance, reporting is available with a relatively exhaustive reporting feature. Continuous integration is also completely possible with the analyzer. And I would say standards compliance features are also part of the package. And I would say with our analyzer, thanks to the exhaustiveness, our vision is that standards are good, but there's ways to go beyond the standards with the analyzer. So what makes the analyzer so special? If we dive deeper into the general terminology of formal methods, first thing, so what is it exactly? Formal methods and mathematics. It's a technology that started in the academic world in the early 2000s. That was originally the first industrial application of it was on niche sector with extremely critical or stringent requirements in terms of code safety, originally, like aeronautics, nuclear plants, etc. But over the years, with increase of compute power, with let's say democratization of the technology and making it easier to use, we have seen this technology now spreading to more mainstream industry. And I would say now this is something that is relevant and usable by any software development organization that has a minimum of safety and cybersecurity requirement. It's exhaustive. So as again, thanks to mathematics, the analyzer will have mathematical guarantees. So there's absolutely zero false negative, meaning that if the analyzer finds nothing, you make the mathematical proof that your software is free of any bugs. It's accurate, no false negative, but also zero or very few false positive, which is often a drawback of traditional static code analyzer that have rules that have, let's say, best effort, not in a negative way, but they're doing their best to detect problems. But sometimes as a result, there's a significant number of false positives that are consuming developer time to investigate, etc., and wasting their time, I would say. It's an analyzer that is as simple to use as running tests. What does that mean? It means that unlike the traditional static code analyzer, the starting point are tests that you will run just like you would with a traditional test framework, but you will run with this analyzer to detect the problems. In general, the experience with other analyzers is that you just provide the code, you run a scan on the code, and you get some results. Again, it's exhaustive, so really it's particularly well suited for organizations that have a certain level of expectation concerning the exhaustiveness of their validation and verification system. It's an analyzer that is designed for C and C++ language. Generally speaking, it works with any code in that language, but is particularly suited for low-level embedded software, and I will explain that later on. Why is that? And it's an analyzer that is focused on undefined behavior, search for undefined behavior in the code. So anything that can cause a runtime error, typically, even if we have some solution for that, we are not much focused on coding standards, like making sure that proper naming convention are respected and type of rules that you can find, for example, in the simple MISRA rules. It's not our focus, even if we have an offer for that. What are undefined behavior? It's the defect in C++ code that are the root cause of a major number of bugs and vulnerability in the field, like buffer overflow, dangling pointer, also called use after free, using array subscript out of range. All these fall into the undefined behavior umbrella. There are way more than that, but that's three, let's say, a very common example of this. Undefined behavior have also that in particular that there are subtle problems. There are problems that do not easily materialize. They can remain unnoticed through traditional tests. They often happen in specific conditions, like after a certain time of execution in the code, under some specific environmental conditions, like sensors that low temperature or I don't know, whatever. And so it's very difficult to reproduce and to troubleshoot during the development phase. And finally, concerning cybersecurity, undefined behavior are traditionally exploited by hackers for cyber attacks to take control over the code, especially buffer overflows. If you look historically in C++, buffer overflow is the root cause of the majority of cyber attacks. So looking at the main analyzer feature, so as I said, the starting points are test, because the analyzer is doing a true symbolic execution of the code. So it will start from an entry point and will follow every statement in the code until the end of the test entry point. And while doing this symbolic execution, it's also doing a control flow analysis. So it's following every branch of execution of code, data flow analysis, every possible value of every variable in the code in the different branches of execution, so that we can make sure that for a particular variable value in a particular branch, there's not a particular condition that is causing an undefined behavior or a buffer overflow, whatever. It's also doing dependency analysis, which verifies that that's particularly useful for cybersecurity. The dependency between variables, how they are impacting their value from each other. That's very often used when you want to make sure that you have a strict isolation between a user space data and kernel space or data that has elevated permission, making sure that a hacker cannot, by crafting special user space input, affect the value of privileged data, like secrets, like whatever can sit in the kernel. The analyzer has also, oh, sorry, I went too far. So I will go back. There's a bit of lag. So, okay, the analyzer has ultra precise target emulation. And that's a feature that is very convenient because in general, during the early phases of the development, or in general during unit test validation, you don't necessarily have an easy access to your target. With the analyzer, you will be able to model all the characteristics of your target, like the CPU, the word size, the Indianness, and a certain number of behaviors of your compiler, the compilation option. And without the access to the physical target and without any instrumentation, the analyzer will do this symbolic execution, taking into account all these aspects, all the low-level address mapping, the memory alignment rules on this target, the padding, etc., to run on host an emulation that is as close as possible to the target. We're not saying that you can get rid of target test execution, because in some standards it's a must step in the validation process. But if you can minimize the number of runs that you have to do on target, and if you clean up your code and detect most of the problem early in the development cycle before you do a last successful run on target, then you have already some significant savings. Okay, so that's really the main benefits. Do the test early without necessity of a specific hardware equipment. And also, if your code is designed to run on multiple different targets, running the same test on the different targets is as simple as switching a parameter and running the test several times from for one target on the other. So it's very simple. Real quick, we also, since the analyzer is based on test, we also, and has special features related to formal methods, we also suggest an adoption path, a way to progressively make use of more and more sophisticated features of the product. This is absolutely not a mandatory process, but in general, it makes the adoption smooth. The first level of usage, called the interpreter mode, is pretty easy to use, because it's as simple as replaying your test. So if you have already a unit test suite that you have for your test framework, then you simply have to replay that test suite with the analyzer, and you are quite likely, this happens often at our customer, to find more bugs related to robustness than to functionality. So unit tests, it might pass, but you don't notice a problem. So you can already find those bugs related to robustness. You get mathematical guarantee. You have 0 false positive and 0 false negatives when you run those level 1 tests. Once you have done this step successfully and you have cleaned up the problems that were already detected, you can move to level 2. This is a step that our customers are doing relatively quickly, because it brings an additional important value of the analyzer through generalization of inputs. So where you were doing your test with only a finite set of discrete inputs, you have a function to test that takes an integer of input, and you're guessing that, okay, maybe I should try the minimum integer, value 0, the maximum integer, and value 42. These are the 4 values I want to test to verify that my code is working correctly. You will change that, and you will do the test with the equivalent of all possible integer values. So that suddenly you increase sharply your coverage, because with all those possible inputs, you are likely to exercise branch of code that are quite difficult to reach with discrete values. So you will see your code coverage increase, and you will also have the certainty, if of course no undefined behaviors are detected, no bugs, the certainty that all the problems in your code have been eradicated. So it's quite powerful. Again, you have 0 false negative. You may have a few false positive. I will not enter into the technicality of that, but still the rate is relatively low compared to traditional static code analyzer. It's quite important to stress that the analyzer will not let any bug go through the analyzer unnoticed. All the problems are detected. Finally, there's a third level of usage of our tool that is only used by a small fraction of our customers, to be honest, because it's quite demanding, but it also allows to achieve extremely high guarantee of the safety and security of the code. It's functional proof. So not only you will test your code for robustness, but you will also have mathematical proof of the functionality. If I would make a parallel with unit test, this is similar, except that unit test will prove or will verify that the function behaves correctly only for a finite set of value. With a functional proof, you would get mathematical guarantee that your function behaves as expected. Regardless of any input, it will have the specified behavior in output. But this is something that is relatively limited to small mission-critical industries and for small piece of code, because you have to do a lot of specification for that. I'm moving on. Hopefully. Okay, so how do you run the analyzer? I already spoiled a bit. I said the analyzer is completely compatible with CI integration. So you have two modes. The command line mode that you can use for scripting and for CI. You have a quick screenshot of an execution with an undefined behavior that has detected. It's the warning here. This can generate all the reports that you need for human and machine readable formats. So for human HTML and for machine JSON and CSV. Then when you face a problem raised by the analyzer, either it's sufficiently straightforward for the developer to know what to do to fix it, or you can run what is called a GUI mode. In that case, it will start a local web GUI, and you have a very powerful debugging and investigation environment that will allow you to understand the root cause of the undefined behavior. Because I told you earlier, these are in general quite subtle problems that are not so always so straightforward to understand. So with this advanced debugger, you will have all the capability to analyze and understand where the problem comes from. Because generally, it does not. The root cause is not on the line where for example, in my case, the sign overflow here, where that problem happened. It originates somewhere else in the code, and you will be able to track back relatively easily. Okay. Standards. Yes, TrustInSoft Analyzer is completely compatible with standards. We believe, though, that its standards are sometimes only a prerequisite to access the market. If you have no standard compliance, you're out. But we have seen that standards are often quite process-oriented, so they will give you the process to try to ensure you deliver sufficient code quality and security. But sometimes there's a bit of a gap. We support standards. We have reporting for MISRA, for CERT. We also can support ISO 26262 compliance. It's worth mentioning that formal methods are mentioned in safety standards since a while. The first one was probably the DO 178C for aeronautics, but now in ISO 26262 for higher level of ASIL CND, you have mention of using formal method as being a good way to ensure the right level of safety. And in cybersecurity standards, it's also coming, in particular, common criteria, which is one of the first. We believe it's not the end of the story. It will spread in future standards in the future because, as I said, with more compute power, more requirements in terms of safety and security that we are seeing on the market, people will have to deliver better software in the future. Standards are although mature, they mature and they evolve relatively slowly. So by sticking only to the standard, there's a risk of being a little bit behind the market reality and the market expectation. So what we are trying to push with the analyzer, without any extra effort, to follow the standards, comply to standards, but even push the limits a little bit further and proceed with exhaustive validation and verification. This is what the analyzer provides you without any extra effort. It's important. Right. The analyzer also provides relatively exhaustive reporting. First of all, in HTML format, you have seen the first slide with a high-level summary of a test campaign with a number of tests that passed successfully and the tests have failed. And when there are some failures where undefined behavior or bugs have been detected, the details of the problem for each of them, which is the second screenshot. It also provides structural coverage information like function coverage, line coverage, statement coverage, and MCDC coverage, like you can see in that that last screenshot, with the details of the code and the lines fully covered, partially covered, and not covered at all. And all those reports are produced, again, both in HTML, that's what you're seeing here, for human read, and in JSON and CSV for machine processing if necessary. We also support continuous integration, and the TrustInSoft Analyzer can be integrated with any CI tool. I will show you an example with Jenkins, because that's one of the major CI tools that we find, at least in the embedded world. So you have an example here of the analyzer integration in Jenkins, and we see that there are 3 steps in the Jenkins jobs that are running 3 different analyses, both on level 1 and level 2. And part of this integration, you can do all what you want in terms of software quality policy. For example, here, the report produced by the analyzer are stored in the build artifact, so that later on you can check, oh, what was my quality on build number 27 last year? Has it improved since then, etc.? You can do that. And second thing, you can have policies like, okay, if I have a test that reports a bug or a vulnerability, I want that build to be marked as failed, so that I don't release the code any further. That's the example you can see here. The build at the bottom and the end with a failure because there was one undefined behavior detected, and then the code was probably fixed by the developer. This triggers a new build, and on that second build, everything was green. So you can consider that the code on build number 10 could be released if it is functionally ready. I'll wrap up. So the TrustInSoft Analyzer is based on formal method. That is a pretty, let's say, unusual technology that provides mathematical guarantee of absence of bugs and vulnerabilities. Mathematical guarantee means that there's zero false negative. We guarantee that we find all the problems, and 0 or few false positive. It has specific features that are specific for embedded and low-level code. It supports standards, provides also comprehensive reporting, and has a flexible CI integration. And that said, if you have further questions, feel free to use the Q&A session at the end, or contact me through the details that are provided here. Thank you. So yeah, interesting question. And I think there are 3 answers to that. First of all, I think it's market driven. I mean, the software industry is nowhere close where it was 10 years ago or 20 years ago. There's software everywhere, and in cars, in all the industry, medical devices, much more than before. And there's the necessity to be safer and more secure on more code than it has ever been the case before. So there's this need coming from the market. The 2 other factors is a formal method, so they are exhaustive, so they can achieve the objective of those industries. But that is only possible if the tool is easy to use. And like 15 years ago, when it emerged in some industries, it was still a formal method was still a technology that had to be used by a mathematician, by people versed into formal method. So it was really reserved to a small niche. But now we see that the tools based on formal methods have become very easy to use. They are used like any static code analyzer, which makes them accessible to a much bigger market. Finally, what helped also this emergence is the fact that to run formal method, to be transparent, you need relatively powerful computing resources that were only available in expensive hardware in the past, but now you can run the TrustInSoft Analyzer on any laptop, mainstream commodity hardware. So it's also unleashing the ability to run everywhere. That's the main reasons to me. Yeah. Yes, that's a good question. So I explained that level 1 is really the most accessible way of using our tool, because if you already have unit test campaigns in place, you just replay them with the analyzer. But then it becomes also at some point very valuable to upgrade to level 2. And to do that, you will have to modify your test driver. Really, the modifications are minor. You will have to add a few lines that are instructions specific to the TrustInSoft Analyzer to specify that all the parameters that you pass as input to function that you unit test are generalized, meaning they can take all the possible value in their range of values, or a specific range, because sometimes all possible values is not meaningful value. So it's only a few lines to be added in the test drivers to migrate from level 1 to level 2 to generalize.